Hey folks, welcome back to your channel on JEE Physics Maniac. So today we are going to discuss another question, keeping the JEE preparation for 2026 in mind. So this is the question which I have taken from Pathfinder Physics. It's a really good question. This is in the chapter of NLM. So let's explore this, and we will learn few allied concepts with this discussion also. So there is a block placed on a large inclined plane that makes an angle theta with the horizontal. This theta is constant, which is mentioned here. Coefficient of friction between kinetic friction between the block and the plane is mu. Mu is greater than tan theta. The block is given a velocity v naught as given, angle phi naught with a line of fastest descent, that is the line along the plane which is mentioned by the dotted line over here. Find the expression for the time interval during which the block remains in motion. Acceleration due to gravity is g. So for that I have taken that along the plane, I have taken this y direction, perpendicular to that it is called x direction, and the block is initially projected with velocity v naught. If we see the subsequent motion of the block, as we can understand that it will gradually move in this way. So here at any instant of time, let me assume that at this point velocity is in that direction, which is along the tangent of the curve. At that point of time, instantaneous acceleration will also be in the same direction. So this is instantaneous acceleration. I'm zooming with this line, that is the line of fastest descent. This angle at this point of time is beta. So I can clearly write that this is the x component of velocity, which will be v sine beta, and along this line we can get the y component of velocity, vy, that is equal to v of cos beta. Right after writing these two sets of equation, so what we got vx is equal to v sine beta and vy is equal to v of cos beta. You will be immensely tempted at this point of time to write that ax is equal to a sine beta and ay is equal to a cos beta. This is a wrong pair of equation. You can't write this. Why you can't write this? Please try to understand. When a particle is moving along this path, at these points, if I draw the tangent, so let us say at this point of time, this is the instantaneous velocity. This angle, let us say it is beta. After some point of time, it comes here. Here is the instantaneous velocity v. If I take this angle alpha, alpha is not equal to beta. So that means the angle is changing. So when the angle is changing, so you have to write ax is equal to d dt of vx, and d dt of vx is equal to v sine beta. Here v is changing, beta is also changing, so you can't write this set of equations, which is a wrong equation. So you have to be very careful. I'll take you back to the constraint relation that you have studied in Newton's laws of motion. If you kindly remember, if this is a surface, here we have taken one pulley over here, and suppose this pulley is connected to a fixed support on the two side of the pulley. I have taken two blocks are there. Let's assume this is block A and this is block B. If this moves in this direction with velocity VA, instantaneously this moves with velocity VB. If this angle is alpha, and correspondingly if we take this angle to be beta, then we can write VA cos alpha is equal to VB cos beta by considering the velocity remains same along the string. So along the string velocity remains same. But if you remember, it was prohibited to write A of A cos alpha is equal to A of B cos beta. Why it was prohibited to write? It is because of the same reason that we have known here, because the angle is changing, correct? So I hope this idea is clear. So once this idea is clear, let us now go into further solution of the question. So let's see what I will take from here. Just allow me a few seconds. So here I have already got two equations, Vx equal to V sine beta, Vy equal to V cos beta. I'm taking this path once again. So this is the line of fastest descent, and here I have the path. At this point of time, I have taken, this is the direction of instantaneous velocity. This is the direction of instantaneous acceleration. With this, it is making an angle beta. So if this is making an angle beta, please try to understand along this line, which force is acting. This is mg sine theta. It's a simple thing, because mg is vertically downward, this angle is mg, this force is mg sine theta. So if this is mg sine theta, what is the other mistake that you will do? You will be tempted to write that the friction is acting in this direction. No, my dear friends, friction is not in this direction. Friction will oppose the instantaneous relative motion. So at this particular point of time, friction will be acting opposite to this velocity or opposite to this instantaneous acceleration. So this is the correct direction of friction, not this one. So this is a wrong direction of friction. This is the correct direction of friction, correct? So now please see, I will take down this one. So this is not the direction of friction, it's a wrong direction. So if this is angle beta, this angle is also going to be beta. I am going to set equations in two directions. One is along this direction, sorry, x, this direction is y. So now please let us check what I am writing. I am writing along the direction of instantaneous velocity. So along v instantaneous or a instantaneous. What is the equation I am writing? Mass into total acceleration, that is equal to, what is the force? Mg sine theta, this component will be cos component. So I can write mg sine theta into cos beta minus friction. So m into dv dt is equal to mg sine theta cos beta minus friction will become mu mg cos theta. Please check if I cancel m from both the sides. dv is equal to, I am writing g sine theta cos beta into dt minus mu g cos theta into dt. I can integrate this result. This result is going to become v naught to 0, right? And this integration of dt 0 to t, this is also going to become 0 to t. So if I substitute the result over here, what I am going to get, minus of v naught is equal to g sine theta integration 0 to t cos beta into dt minus of mu g cos theta into capital T. So I will segregate this result over from here. So 0 to t cos beta dt is going to come mu g cos theta into t minus of v naught divided by g sine theta. So this is the first equation that I am getting from the analysis, right? Let me see. This is my equation number 1. And this is what direction I have taken? Direction I have taken, this is the direction along the instantaneous acceleration. So this is the direction I have taken. Next I am going to take along y. So my next direction is going to become along y. Please check along y. Along y, which force is acting? Along y, only mg sine theta is acting. So I can write m into ay is equal to mg sine theta minus friction cos beta component will act. So I can write small f into cos beta. Let us rewrite ay is equal to g sine theta minus mu mg cos theta cos beta divided by m. Gets cancelled. So dvy is equal to, I am getting g sine theta into dt minus mu g cos theta cos beta into dt. Integration once again, this integration. This is integration 0 to t. This is integration 0 to t. Since beta is variable, so you see tactfully I have kept cos beta inside the integration. I did not put it out of the equation. Now dvy, if you check dvy, initially what is the velocity along this direction? Along this direction is equal to v naught cos phi naught. So my limit will be from v naught cos phi naught to 0. Eventually this becomes minus v naught cos phi naught is equal to g sine theta into capital T minus mu g cos theta integration 0 to t cos beta dt. So again, integration 0 to t cos beta dt. What we are getting, everything will be positive. So we can write v naught cos phi naught plus g sine theta into t, that divided by mu g cos theta. So this is my equation number 2. And both the equation what I have calculated the value of integration 0 to t cos beta dt. So now from 1 and 2, I can equate the result from 1 and 2. If I equate, I am getting mu g cos theta into t minus of v naught divided by g sin theta, that is equal to v naught cos phi naught plus of g sin theta into t divided by mu g cos theta. If you cross multiply, you will get the equation required for t. So I hope you have enjoyed the video. You have learned the concept. There are two very crucial points that I have discussed in this particular question. Whenever you are going to solve similar kind of questions next time, be careful, and you know what is your next target is to build the questions around this, what can be applied, and learn what not to be applied. Thank you so much. If you like the content, then please do like, share and subscribe. Thank you. See you in the next video. Bye bye.